Hi everyone, let's take a look at tutorial 9 question 1. A random variable s is distributed according to a log normal distribution, and we're given that L is log of s, and we're also given the mean and the standard deviation. Okay, so a few things to say about this. Well, S could be the share price of some stock. We know that if we take the log of the share price, this follows the normal distribution. So this question is just checking we can follow routines in this area. Okay, so since S is log normally distributed, there's a few things we can say. The first one is that the random variable L, which is just log of the random variable S, follows this normal distribution with these parameters as stated in the question. And we're given these numbers. L is log of L bar, maybe do a different color. L bar is the average or the mean value of L, and sigma squared is 0.1 squared. Okay, we need to find the probability that S, so maybe this is the share price, S is less than 200, so maybe the share price is less than £2, something like this. Okay, we don't know much about S, but we do know about log of S. So it makes sense to take a look at this condition here and rewrite it in terms of something we know. So naturally, we're going to take the log of both sides. Okay, so these conditions, we're taking probabilities on these conditions. They're the same, or they're equivalent. Right, so we have log of S by here, and we know this follows the normal distribution. So standard process, we're going to normalize. So if we normalize the left-hand side, this just becomes Z, the standard normal distribution, and on the right hand side we're going to subtract the mean and divide by the standard deviation, which is the same as the probability that Z is less than minus 2.2314. Okay, our tables don't give us the full picture. We don't have the negative values, so we need to state an equivalent equation, if you like, with the positive values, or equivalent probability, I should say, with positive values. So we're going to write this as 1 minus the probability that Z is less than 2.2314. So the rule I'm using here is the probability Z is less than some negative number. I'm going to choose maybe A, is the same as 1 minus the probability that Z is less than A. And we can see that from a sketch. So if you draw a picture, look at the symmetry. That's easy enough to prove. Okay, we can just assume that's true. Right, now we can use our tables. So the probability that S is less than 200 is 1 minus this probability. Okay, so how are we going to find this probability, given that our tables only use 2 decimal places? Well, there's two ways to do it. Method one, which is the method I prefer, you just round this number. This is the easier approach. And this is the one that makes the most sense to me. We're rounding, so we're going to lose a little bit of information. If we wanted something more accurate, then I think we should just use the computer. So for me, this is the preferred method. I would write something like this, and then I would just, oops. And I would just round, so I would do approximately Z is less than 2.23, which is, using the tables, about 0.9871. So we have about 1.29% chance of the random variable S being less than 200 under this model. Okay, so like I said, this is my preferred method. If you were to do this in any assignment or in an exam, I would award the full marks for that, unless the question said something more specific, like use interpolation to estimate your answer. So then I'd expect the other way of doing it, which I'll go through now. So method two. Is called interpolation. So using interpolation, maybe the question will say linear interpolation, we're just drawing straight lines. So let's talk through that. Okay, I think a picture is quite helpful. So if we think about our standard normal distribution, so just think about Z. Okay, so we have a picture, something like this. Now, I don't want to squeeze everything on, so I'm just going to use a scale, which obviously is a bit silly, just so we can get a clear picture. If I assume this one is 2.23, then I know the scale's not great, but I'm going to call this one 2.24. Okay, and I'm just going to label these points. Let's call them A and B. Okay, so I should say, why did I choose these? Well, if we take a look at the number we want, oh, that's terrible color. If we take a look at the number we want, which is 2.2314, well, it's somewhere between 2.23 and 2.24. Okay, so I'm just going to draw it on. Again, I'm not going to worry too much about the scale, maybe somewhere by here. This point is 2.2314, and I call the point on the sketch, on the curve, call it C. Okay, so here's interpolation. We're going to, actually, I think I'll take that C off. It's just the point on the curve. Okay, so interpolation, what we do is we draw a straight line from A to B. Okay, that was terrible. Do that again. Roughly by there. Okay, so the interpolation is linear, which means draw the straight line. And we're going to estimate the area that we want by just assuming that point on the curve is roughly the same as that point on the line. Okay, so my scale's not great, so it looks quite different, but actually these numbers are much closer. So actually it is going to be a lot closer than what I'm suggesting from my picture. Okay, so how about the calculation? Right, so we know, we're going to look at areas. So we know the areas using the CDF, the cumulative density function, which is just the n values. This is the area on the left of x. And we can see, if we take a look at this total area in here, there's a few patterns we can see. The most important is the rate of change of area. So if we look between A and B, the change in the area is this. So the N 2.24 is the area on the left of B, and the 2.23 is the area on the left of A, the line coming down from those points. So if we subtract them, we get that shaded area. Well, the rate at which that area changes, so I'm going to divide it by the length of the interval, the Z interval. This gives the rate of change of the area from A to B. Well, all those lines from A to B. Just gonna give myself a bit of room. So if I just move this to here. Well, we know that the area is changing, the rate of the area is constant because of the straight line. So I could look between, call this letter C. I could look now between A and C, and I would know that the rate would be the same. So the rate of change of area from A to C, well, I know this is going to be the same as from A to B. So let's work out the change in area. So this is the shaded area going left and right. So the double shaded area. So the change is this, and the rate of change, so I need to divide by the length of the interval. Okay, so that completes this equation, and the most important feature is everything is known except this value, which is actually what we want, to calculate. So when I was doing all these, building all these ideas, really I had my eye on this. Okay, so if I rearrange, I can find the area to the left of that purple line. Okay, it's just to calculate the job. You might need to use the tables for those other n values. We get 0.987142. And if we drop that number into our question, okay, we're going to get something slightly more accurate. So now I'm going to put this number into this thing up here. So I end up with the probability S is less than 200 is 0.012858, or about 1.2858%. Okay, so just a few concluding comments. Firstly, this makes sense because we calculated this number using rounding, and this is not too far away. Okay, so that gives us some confidence that we've done something right. And the final remark I want to stress, really, if we're looking for something quite accurate, then it makes sense to use a computer. So I always prefer to use method 1 unless the question explicitly says use interpolation. Okay, so there you go. There's my complete answer to this question.